Hello everybody, today we're gonna see how to use Aspen Plus in order to evaluate or test the miscibility between two chemical compounds or maybe three or four or certain chemical compound. I'm gonna select polar and non-polar chemical compound and see how this kind of simulation software predict or how is it accurate. So let's start by opening a new fluid package or a new page. I'm gonna to create a blank simulation. Uh, it asks me either to save the previous work or no. So I'm gonna to open a new one. I will not save it because I already tried before, so it's a repetition. So the first page appears to you is the page that you have to select or to list all the chemical compounds you wanna use it in your simulation. So click in find and start writing your chemical compound. I'm gonna to use a water as a polar compound and any hydrocarbons. I'm gonna to select any type of hydrocarbons as the non-polar component. So I'm gonna to write water, then find now. In this table below, it will show you all the potential or all the chemicals that contains the name of water. So as you see here, this is all the list of all the chemicals that contains. Uh, okay, I'm gonna to use a pure one, a pure water. So just click twice, or maybe yeah, and then add. So for non-polar component, I'm gonna use, let's say, hexane, maybe pentan, octane, nonan, dodecan, any hydrocarbons. Actually, hydrocarbons, all the hydrocarbons are non-polar components, so you can use any of them. In order to find accurate uh, results, you have to click in equals, so it will give you only hexane here. Then also add a component to the list, then close, then click to next. It will take you to the second page, which you have to select the model of your component. So uh, the common or the popular model that they often use it for non-polar and polar component is the NRTL. So NRTL is the appropriate model. You can use it for the polar and non-polar mixture. Then go next. Uh, okay, an exam. I think I have an issue here. Oh, I add twice of water, so I'm gonna to delete one. I'm gonna to delete this one because I put twice of the water, so only one. So in order to make it easy and simple, I'm gonna to use just two components, polar and non-polar, to see the example or the sample how to use Aspen Plus for predicting the behavior of liquid base. So then go next. Okay, then click to the simulation section. In the simulation section, I'm gonna add a decanter, which is a unit that they often use it for a separation. If you wanna to separate two components, so the decanter unit is the appropriate or the suitable one. Actually, decanter, the function or the role of decanter is separate the liquid depending or based on the liquid behavior. So for for more accurate result, you have to use a decanter. As you see here in the bottom of the screen, there is a list of units or yeah, the unit, all the units that you need. So you have to go to the separators and choose decanter. Then add the stream flow. As you see, if you put your mouse inside of the decanter, you can see that there is three rows. There is only one row for input and two rows for the output. So just you have to put your mouse in the input and then click on it. Move your mouse till uh, till you see there is a new stream. Sorry, I made a mistake. So just click in material, then move your mouse in these rows. So as you see here, for input we have S1, and for output we have S3, S2. I think this is this is I think this is S3. Yeah, this is S3 and this is S4. So then next, click twice, click two times in S1, and it will show you new windows with which you have to insert all the operating condition. So for here, for temperature, we're gonna to write 25 degrees Celsius, and for pressure 1 atmosphere. I'm just pretending, or I'm just simulating the ambient temperature for the operation condition. Uh, and then here you cannot you're gonna you can choose either mass, mole, or volume. So let's try for this example. Let's try with mole fraction, and here for mole fraction, then choose mole fraction. Here mole fractions, you have to put uh, any fraction you want. I will make it identical. I will make it equivalent. So I will put 0.5 for water and 0.5 for oxygen. So the total it will be 1. Then go next. It will take you to the unit, which is the decanter. And you have also to insert the operating condition. I will do same as I did for the first stream. 1 atmosphere for pressure and 25 degrees Celsius for temperature. Then next, after that, you can see here in the bottom, it shows you, or it detects you that you already fill up the requirement. So just click and run, and the simulation will start processing. uh, so let's wait a minute. It is calculating. So here, as you see here at the bottom, at the right bottom, sorry, my record was interrupted, so I'm coming back again. As you see here at the right bottom of our screen, the result is already available, so the processing is already finished. We go back to our main flow sheet, and in order to see the results of our mixture, we can click either in S3 or S4 by our by the right click in your mouse, and then select results. What we're gonna see here is the table, and this table includes 3 columns. Each columns refer to one stream flow. So for S1, is our input or our flow stream input, and for S3 and S4 is the output, and our result, our main result, you can see it here. In order to detect or to determine either our mixture is totally miscible or immiscible, you just can check these two columns, S3 and S4, has a numbers or values. As we see here, as you are seeing here, our tables or our two columns includes numbers. This give us a hint or a clue or maybe an evidence that our mixture is totally immiscible and is not homogeneous together. It is heterogeneous. So for more detail, you can click in the more flows and you see your component here, your selected component. So let's say for water, in the water line, we introduced 50 kilomole per hour, and the result for the first way give us 49, which is approximately near to 50, and for an hexane is almost zero. So it means that the first phase is rich of water and no hexane here. But in the second phase is the opposite of the first phase, which we have here approximately or almost 50 kilomole per hour of hexane and zero of water. So this is the best idea or the best strategy to see how the homogeneity or miscibility of your chemical compounds by using Aspen Plus. Uh, I hope I uh, I hope I convey the idea of evaluating the miscibility using Aspen Plus. Uh, in order to, let's say our mixture is totally miscible together, what you're gonna see here, you will see only one liquid phase or only one column, and the second column is empty, is totally empty. We can like try an example by using only one component, like we're gonna to go to uh, S1 and then input and then change the mole fraction. So we're gonna to eliminate or delete water and put one mole fraction for an hexane, then run the simulation. So after that, at the result, if you go to the result, we will do same as we did before. You're gonna see, oh sorry, S3 and go to the results. Yeah, you're gonna see only one column has numbers, but for the second one is totally empty. So this is how to use Aspen Plus for determining Aspen Plus. I hope I expressed the idea or the lesson of this video. So thank you for your watching. Thank you for your patience. Don't forget to, if you have any confused questions, any comments, just write it down below this video. I'm gonna try to answer all of them. Your comment and your like is so mean for me. So thank you again. See you next time in a new video. Thank you.